Welcome to another session of sequences and series. This is part 6. In this video, we discuss about series and sigma notation. The mathematical symbol sigma is used as the symbol for summing a series. It's a Greek letter. Consider the following series. Sigma k equal to 1 to n of tk, which is equal to the sum t1 plus t2 plus t3 plus t4 plus up to tn. This is read as follows: the sum of all the terms tk. Tk is the general term from k equal to 1 to k equal to n. Okay. Question: calculate sigma k equal to 1 to 5 or 4k minus 3. What is this 4k minus 3? That is the general term of the sequence. So the method, we substitute values for k starting from, in this question, it is from k equal to 1 to 5. Okay, so we substitute k equal to 1, k equal to 2 up to 5, and we get all the terms. Look at the values. 4 times 1 minus 3 plus 4 times 2 minus 3 plus 4 times 3 minus 3 up to 4 times 5 minus 3. It's a simple example. We simplify that. We get all the 5 numbers and we can add them easily. Another example. Calculate sigma m equal to 0 to 4, 5 times 2 to the power m. That is another geometric sequence, exponential. We use the values for m starting from 0 up to 4. Carefully substitute and use the calculator. We get all the numbers. Answer is 155. Calculate sigma m equal to 3 to 67 of 8m plus 2. So here we have a lot of numbers. We are not going to write all of them and add. Instead, we find what sequence is this by writing 2 or 3 numbers. Okay, we can write all the numbers, but here it is 60, more than 60 numbers, so it's not possible for us. So we write the first 3 numbers and the last number and checking what type of sequence is this. 26, 34, 42, etc. So we realize that it is an arithmetic series. The first term a is 26. The last term is 538. Now, how many terms? The number of terms must be calculated. The method is very simple. We have m equal to 3 to 67. 67 minus 3 plus 1 will give us the number of terms, that is 65. Remember the method. 67 minus 3 plus 1. Okay, so that is the technique for getting the number of terms. So we have 65 terms here. First term is available, last term is available. arithmetic series. So we use the formula for that from the formula sheet. N over 2 times A plus L, which is going to be as 65 equal to 65 over 2 times A is 26, L is 538. Use the calculator, we get 18,330. Simple. Indirect question here. Calculate the value of n if sigma k equal to 1 to n. 2 times 3 to the power k minus 1 equal to 531,440. So the sum of the series is available here. It is given. We have to solve for the number of terms n. Okay. So start, we write the terms and make sure that the sequence 2, 6, 18. Okay. So we realize that it is a geometric sequence or series. We can also see that 3 to the power, when it comes to the exponential pattern, you must know that it is going to be a geometric series. Now we have A is 2, the common ratio 18 divided by 6 or 6 divided by 2 will give us, the common ratio is 3. We have the sum of the terms is also available. Now what is our question? Solve for the number of terms. So we apply the formula for the geometric series. A times r to the power n minus 1 divided by r minus 1, because the common ratio is greater than 1. So we substitute the numbers very carefully and solve for n. We get 3 to the power n minus 1. Okay. In the denominator we have 2, numerator also we have 2 cancelled. So we write 3 to the power n is equal to, moving minus 1 to the right side, we get 531,441, which can be written as 3 to the power 12 from the calculator. Therefore, the bases are equal. Now, the exponents must be equal, n equal to 12. Given sigma 101 minus 2p, p equal to 1 to n. What is the question? Question A, write down the first 3 terms of the series. So we know that, substitute the values for p, we get 99, second term is 97, third term is 95. So the first 3 terms are 99, 97 and 95. Question B, calculate n for which sigma 101 minus 2p equal to 0. The sum is 0. And solve for n. As in the previous question, we take A. Now here it is a arithmetic series. We have Sn equal to 0. Use the formula for the arithmetic series that is available on the formula sheet. Substitute the numbers and then we solve step by step. N times n minus 100 equal to 0. N equal to 0 is not applicable. N cannot be 0. Therefore, n equal to 100. That is our answer. Again, determine m if sigma k equal to 2 to m of 1 over 15 times 3 to the power k minus 1 equal to 24 and 1 over 5. Okay, first we must know the terms. Okay, we substitute starting from k equal to 2. Okay, Then we write all the terms. We get 0, 2, use the calculator, 0, 6, 1, 8. Okay, and the sum is 24 and 1 over 5. So we realize that it is a geometric series with a equal to 0, 2, r is 3. Okay, divide the second term by the first term. And n, how do you calculate the number of terms? Okay, we are going to calculate m minus 2 plus 1. Simplify, we get m minus 1. Okay, so we got all those necessary numbers. Now the sum is also available. What is the sum? 24 and 1 over 5. We are going to solve for m now. Substitute into the formula very carefully. Sn is 24 and 1 over 5. A is 0, 2. R is 3. N, remember that n is, in this question, is m minus 1. Then r minus 1 denominator, that is 3 minus 1. Okay, now the rest is to solve the equation. Okay, 24, 2, okay, is equal to, then we cross multiply and divide by 0, 2, that gives us 3 to the power minus 1 minus 1. Simplify again, we get 242. Then 3 to the power minus 1 is 243, which can be written in powers of 3. That is 3 to the power 5. Therefore, m minus 1 equal to 5. Therefore, m equal to 6. That is our answer. A good question. Write the following series in sigma notation. 2 plus 5 plus 8 plus etc. 83. So we know that when we have sigma notation, we write the general term in front of the sigma notation. So our first job is to calculate the general term or the nth term. Okay, let us start. Here is the first term is 2 and common difference is 3. Now, what is the formula for general term? Tn equal to a plus n minus 1d. Use that formula from the formula sheet. Substitute and simplify. We get Tn is equal to 3n minus. That is the general term we are going to write in front of the sigma notation. Now our job, how many terms we have to solve for n? So Tn is available. The number of terms are going to be calculated using the last term, the Tn, 83. Okay, 83 is available here. We write 83 is equal to 3n minus 1, or 3n is equal to minus 84, or n equal to 28. So there are 28 terms. Now we use the sigma notation for the sum of the series equal to sigma n equal to 1 to 28 of 3n minus 1, the general term. That's the method, good people. You must know that method very clearly explained here. Write the series 2 plus 6 plus 12 plus 20 up to n in sigma notation. So this is not an arithmetic, this is not geometric, this is seemingly a quadratic sequence. So we continue until we get the general term. Okay, we already learned. So we continue the first differences. Okay, we write the first differences. Then we go for the second difference. We already learned this quadratic sequence in part 1. Now look at the values of A equal to 1, B equal to 1, C is equal to 0. What is the general term? Tk equal to k square plus k. Now you can write this general term in front of the sigma notation. Okay, so this series is written in sigma notation. K equal to 1 to n. That's why we use, because we have to use n here, that's why we wrote the general term as tk, not tn. Okay, so we get k square plus k as the general term, and this is the sigma notation. That is the end of part 6. We learned how to answer the questions involving sigma notations. Watch again and again until you are sure of the methods. Try to score the full mark from this type of questions. Okay, good luck.